We are going to go through Chapter 1, Getting Started. You'll notice as you go through that there are links to external sites, and this was done to keep the number of pages in the ebook low because that affects the price. So that is why you will see so many links. So the first link, Chapter Summary and Learning Objectives, gives you an overview of what you will be learning in the chapter. And then by the end of the chapter, these learning objectives are things that you should know. And you'll notice throughout that there are also examples, lots of examples that are linked in that you will have to select and read through. The coding examples have their own videos that you can watch. So I'm not going to go through all of those during the chapter videos. And if you're running through the chapter, you'll notice that there are sections that you can click and go directly to. And there's also some subsections. But if you don't need the table of contents open, you can actually close that. And that gives you a little bit more room to view this. And anytime you notice that the text is fuzzy, you can certainly zoom in and zoom out, using your browser. So now mine is at 100%. Okay, and so that's just kind of up to you, how you want to view the page. I'm actually going to zoom out a little bit. I have a very large monitor. So what is C#? C# is an object-oriented programming language that runs on the .NET framework, and it was developed by Microsoft. It is used to develop web application, desktop applications, mobile applications. You can develop games in C#. Unity is a game framework that is C# based. And there's a lot more that you can develop in C#. C# is derived from C and C++. And those languages have been around for a really long time. And it is very similar to Java. And Java is not the same thing as JavaScript. JavaScript is a language that is embedded into HTML. So it's a web language. Java is a traditional programming language. It's a higher level programming language, just like C#. After you learn C#, it is easier to pick up additional languages without a large learning curve, because the concepts in these programming languages are pretty much the same. So it's just a matter of learning syntax. To code C#, you need to use an IDE, and that's short for Integrated Development Environment. The easiest way to code C# and the C#.NET frameworks is to use Visual Studio. Visual Studio Community is free, okay? And that's what we use at our campus. Another IDE that is popular is Eclipse, and you can certainly code C# in that as well. VS Code is another IDE. Mac users will have to use VS Code. In this class, the examples and everything we do is just focusing on basics. So you will be doing console applications. And it's relatively simple to do the console applications in VS Code. It's a lot more complicated to code the frameworks in VS Code. What is .NET and the .NET framework? So the .NET framework is part of .NET. .NET is like, it's a larger umbrella, and it's a free cross-platform open source developer platform. And it lets you build many different types of applications, which we just call apps. And if you use .NET, there are several different languages you can code in, C# being one of them, F# and Visual Basic. Those are the three. And there's several different ways to create full stack web apps, mobile applications, and desktop applications. The .NET framework, as I mentioned, is part of .NET. And there's two major components to that. There is something called the Common Language Runtime, and that is abbreviated CLR. And then there is the .NET Framework Class Library. And the CLR handles running the application. And it provides services like thread management. And I'm sure a lot of you don't know what a thread is, but when you run any program on the computer, it has to run on the main thread. And there are ways for you to run multiple things by creating additional threads. Garbage collection occurs when you are not using a resource anymore. So sometimes in a program, we may use a resource like a file, or we might create an object, and then we're done using it. Okay, so garbage collection kind of removes it for us. Type safety is built in, and that deals with making sure the data types are accurate. And C# is a strongly typed language. And so you can't create a variable and say it's going to have numbers with decimal places in it and then try to put text into it. Okay. It won't let you do that because the data types are different. Exception handling are errors that occur when a program is running. And there's quite a few different ways that we handle those. We will be covering exception handling in the last chapter. The class library includes a set of APIs. And for those of you who don't know what an API is, it is an application programming interface. It is basically a way for computers to communicate with each other and share services. And the class library includes a lot of routines that pretty much all programs use. So example would be reading data that people type, okay, reading in from the console, or writing a message to the console. Those types of things are handled by the class library. The class library includes classes for all of the different data types that we're going to use. In addition to reading and writing from the console, we can also use it to connect to databases, to read and write files, that type of thing. So anything that you want to do in C#, if there is a class already built that handles the function, then you should use the class because that code works and it's been debugged and it's standardized. Okay. The only time we really have to code something out ourselves is if the class library does not have anything to handle what we want to do. C# is a high-level coding language, which means that, it's English-like. We can read the code. And the computer cannot run a high-level coding language program until it is compiled and processed down into the machine code level. And I think the easiest way for you guys to understand this is to take a look at this graphic, okay? Because I have included kind of the process here. So you've got your code that you've typed up in your IDE, your interactive development environment, okay? And then what we typically do is we give a command to run. And that's when kind of the CLR takes over and it compiles it. It creates a common intermediate language file. And then what the common language runtime does in this process is it uses something called a just-in-time compiler, which is kind of the most recent version of the compiler, and it converts our higher level language down into machine code. So all of this kind of takes place behind the scenes. So all we basically do is hit run. And if there's no errors, the program executes. But all of these steps are happening in between. Okay, and that's what you have to be aware of. Now, if there is an error, we are not going to get to the program execution stage. Okay, and it's not going to be converting the code into machine code. What is going to happen is that the compiler quite often will catch the error if it's a syntax error, and it will display information to us so that we can fix it. Okay, there are times when it compiles, it gets converted into the machine code, and it'll start to execute. While it's executing, it may have a different type of error. Those are called exception errors or runtime errors. Okay, so we'll take a look at the 3 different types of errors a little later in this chapter. Program structure. So it's kind of important before you actually start working in C# that you understand how the programs are put together. And I think what I'm going to do is create a quick program here in Visual Studio. And right out of the shelf, it is going to put code in here for me. I'm just going to do a little console app, and the language is C#. And over here for the type of app, it is a console app. I'm going to choose this. And I'm going to say Chapter 1 Demo. Okay, so this is showing me where it's going to put it. And by default, it puts it into a repository folder. And that folder is on your C drive. Okay, and it is under users. And you find your username. And then if you scroll, you should see source. And then inside source, you find repos or repository. So that's where it's going to put it by default. Now I'm going to open up my folder for the course that this is associated with. And down here, I did indicate to place a solution and the project in the same directory, because the solution file is a way for you to enter the program after you exit out. I'm going to click on next. Because you are learning, you should turn on do not use top level languages. because I want you to see all the code. If they use top level languages, a lot of the structure of the program is going to be hidden. And that's not really good for beginners. You should be looking at all the code. Oh, and I should mention, as far as the framework goes, you want to pick the one with long-term support. And they come out with new frameworks all the time. So right now, it's .NET 8. I believe they're coming out with .NET 9 soon. And usually every other version has long-term support. So right now, .NET 8 has long-term support. For what we are going to be using in class and in this book, anything beyond .NET 6 is fine. Okay, so this is the basic program structure that I wanted you to see. And you'll notice that we have a namespace. And by default, it made the namespace the same as the project. You can change it. The namespace can actually be whatever you want. Okay, then inside the namespace, we have a little class that is called program. And inside the little program class, we have a method, which is just a routine called main. So by default, this is what you get right out of the box in a brand new console application. So C# automatically, if you use Visual Studio, it's going to build this out. Another thing that it does, I did not point out, and you can't see it, but it has automatically pulled in the system class and the system namespace. So what it does is you don't have to key in using system. Okay. It automatically pulls that in for you. And system is a namespace. Okay. So, and it's a namespace that's located in the C# libraries. Okay. It's not a namespace that we're creating. So, I mean, if you want to put it in, you can. If you are not using Visual Studio, you may have to put it in. And the system namespace actually allows us to read and write from the console. So if you are using something other than Visual Studio and you are getting an error here on this line, it's probably because you need using system. Okay, so C# does have a lot of library classes and methods, as I mentioned, that are used to input and output data. There are also libraries and classes for all the different math operations. There are classes for reading and writing from files. And in order for you to use any of those routines, you have to add a using statement that brings in the namespace for the class. And the namespace includes everything that's in the class. So including that using statement allows you to use those methods or routines that are in the class, and you don't have to write them yourself. One standard is that all C# code is placed into a namespace. This allows you to easily share with others. As you can see, we were able to pretty easily pull in system, and we can read and write to the console now. And actually, as I mentioned, it's done by default. But the other classes are not pulled in by default. So we will have to pull in their namespace. A namespace is a unique identifier that is associated with a class or multiple classes. And a class contains variables, which is just like storage containers. We'll be talking a little bit about those in a few minutes. it contains methods, which are just little routines, and it can also contain properties. And we are not going to get into properties for several weeks. Without namespaces, what would happen if we wanted to share our classes with others is we would probably have something called naming collisions. And the best example of this is if you've got multiple programmers working on a project. And one programmer, developer Chin, wants to create a class named date. And it's going to do some date manipulations. And then another developer working on a different part of this project, developer Lopez, also wants to create a class named date. And his class is going to do something completely different than developer Chin. For both developers to do this without creating duplicate class names, because they both want to call their class date, they need to place the class in a namespace. Okay? And the namespace name would then be unique, because you can literally make up a name for the namespace. So highly unlikely that they would both have the same namespace name. And so when you are creating a namespace, typically you give it a name that relates to the project that you're working on. So as far as C# goes, you can literally call it anything you want. Okay, so by default, it took the project name and made it the namespace name, but I actually could replace this with garbage. Oops, as long as I don't key any characters that it dislikes, it will totally let me do that. Okay, so it does not have a problem with any of that. Okay, but you just want to be careful about the special characters. So any letter is fine. I think it also lets you do numbers. Okay, no special characters. And right below the namespace, you have to have an opening curly brace. And then at the very bottom is a closing curly brace. Visual Studio is kind of nice because as you get into coding, you're going to have a lot of curly braces. And sometimes people get confused, like, okay, what does this ending brace go with? And if you point and pause at the close, it'll tell you what that closing brace goes with. Okay, and so this is the syntax that I just showed you. Inside a namespace, we have a class, and a class is just a logical unit that it is going to declare data, okay, the name of the data and the data types that you're going to store. And then methods are just little routines that work with the data. So it's kind of like a blueprint or a prototype that you create objects from. And the objects would include all of the data, and then they would have access to those routines that manipulate the data. And the syntax is you have class, and then a class name, and then you would add your code. Okay, and I should have pointed this out. The class does require an opening and closing curly brace at the beginning and the end. Now, within the class, we are going to have, our variables, our data, and we're going to have methods. And a method is just a routine. So it's like a little block of code, a little chunk of code that has statements that will be executed when the method is called. Sometimes we pass arguments or we pass data to a method so that it can run correctly. And other times we don't have to. A method that we use from day one is called WriteLine. WriteLine is in a class called Counsel. And this is part of the system namespace. Okay? And because we didn't create the WriteLine method, we're going to prefix it with the class name Counsel, dot, and then the name of the method. And then you'll notice that we have a left and right parenthesis. Methods always include a left and right parenthesis. It can be empty or it can have arguments in it. If you don't pass any arguments to WriteLine, it will write out a blank line. If you pass an argument, it will print out your text. Now, you may have noticed in our little example that by default, we have a class called program, and we have a method called main. Every program has a main method. The main method is required, and that is where the program starts to execute. So any code that you have inside main is going to be automatically run. And there is more than one way to code main. Now, the default that you just were looking at is this little method here, okay, where we are allowing some arguments. The arguments are optional. Okay, we could also code it this way with no arguments. Where would the main program get arguments from? Some people will run the program from a command line. And if you run it from the command line, you can pass data to the main method. And this is where the data is brought in. Okay, and I do have some examples here. We scroll down. These are pretty simple examples. This is just like the one that I just showed you. All right. And again, the using is automatically included in Visual Studio, but it may not be in other editors. And then we have our namespace, we have our program class, and we have our main method. And so here is another very similar example. You'll notice that I changed the text that's being written out, but otherwise it is almost the same. And so if I wanted to, I could remove this, okay, because we're not going to pass any arguments there. And I can change this. And then to run this, all we have to do is click on the run button. Now, remember that CLR is going to take over. So it's going to use the just-in-time compiler. It's going to be converting it to object code before it actually runs. Okay, and that is what it looks like when it runs. Now, depending on your system, sometimes people don't get to see this box. So this is the console. I've had some students where the console is behind Visual Studio instead of in front. So you have to look down, in your taskbar to see it. And I've also had students where it flashes and closes. So if that happens to you, you can do something like this at the very bottom to pause your screen. Okay, so that it does not just run and flash. Okay, so you can see that all that additional ending code isn't there, kind of paused it. And now if I press enter, it's gone. Okay, so this is kind of optional, just depends on, what IDE you're using. As far as writing programs go, syntax are rules that you need to remember when you code a language. Every language has its own syntax. And if you don't follow the rules, you are going to get errors when you try to run the program. So what does that look like? I'm going to make a mistake. I'm going to misspell the method. All right, so right away you can tell anytime you see a red squiggle, you guys know there's a problem. But if you point and pause, it does try to tell you what the problem is. But if for some reason you don't notice it and you run, it is going to come back and tell you there's a problem. And then it's going to say, would you like to continue and run the last successful build? I always say no, because there's a problem that you need to fix. So you're going to say no. And then when you come over here, you'll see the error. And if you're not sure where the error is, you can double click on this and it should take you to the error. Okay, so you double click, takes you right to the error. And the nice thing about Visual Studio is it does show you potential fixes. Okay, and this happens to be the correct one. So that fixed my problem. Now let me do another error. And forgetting a closing double quote is really common. So let's do that. And so that's one thing I did, and it produced several errors. So you always want to go to the first error, the first occurrence, because sometimes just fixing that is going to fix the problem. Okay, so I double click and it's taken me to this location. And if I point, it's not super easy to understand that you are missing a double quote, but it's trying to show you, here's the beginning one, and then here's where I'm missing the end. So once I put the ending in, if you look at the errors, they will all disappear. Okay, and now they're gone. Okay, so sometimes, where it takes you, like here, wasn't super helpful, but then if you look, syntax error, comma expected, right parenthesis expected. So it's super confused at the end of this. And that's where the other error is being flagged. So it's just a matter of kind of visually looking, and it's really not too hard to find. And I think a lot of people make the same kind of mistake over and over again. So you will learn what kind of mistakes you make and you'll become really good at fixing them. So some other syntax, C# is case sensitive. So upper and lowercase letters are not the same. So I'm going to illustrate this. I think this is the best way for you guys to see this. So let's say I have a whole number. The data type is an integer, and I create number. Okay. And now I want to take number and I want to put 20 into it. And I do this. Okay, now, oh, I think it corrected it. Let me see. All right. So if I do that, number is flagged. And that is because number in all lowercase letters is different than number with an uppercase N. They are not the same. Okay, because this is a case sensitive language. So you need to kind of keep that in mind when you are coding. Another thing to remember is all commands end in a semicolon. And a text phrase, which is called a string, is enclosed in double quotes. In fact, I can take this and copy it. And I can paste it right in here. Whoops. Apparently it didn't like that, so I guess I will not be able to be lazy on this. Getting all sorts of errors here. And first name. Okay, so doesn't matter if it's multiple of words or one word, it needs to be in double quotes. So you may wonder, how come the number and first name have the green squiggle? Like, you understand that the red squiggle is a problem. But this just means that they haven't been used in the program yet. Okay, so it's okay if you see this. It just means we haven't used them anywhere. Comments. Anytime you want to convey information to others that may be working on the program eventually, you can add a comment. If it's one line, you just do // and then enter your text. If it's going to be multiple lines, you have the opening, which is /*. You enter your comment and then you close it with an */. So comments are used to convey information. They are also used, if you have a problem in your code, like I swear it keeps lowercase in that. So if you have something like this and you don't know what the problem is, you can comment out the line. Okay, so comments are super useful for debugging. If there's a section of your code that's not working, you can comment out the section. So I could actually choose to comment these 3 lines. So I put the opening comment in and the closing comment. So comments are super useful. As far as coding standards go, programs are written using a series of commands. The commands in a program are executed from the top to the bottom, and each command has to end in a semicolon. The processing of your program is going to begin at the main method, and it is a standard to only include one command per line. And you'll notice that the code is indented, and your IDE will do the indenting for you, but it's typically indented 4 spaces. So if I was going to add more code here, you'll notice it's indented. If I'm going to add an if statement, which you'll learn in a couple weeks, if continue, oops. Do something like this. And I have to make the name unique because right now it is a keyword. All right. Okay. You'll notice that if I create a little block here with an if statement, it automatically indented the next line. Okay, so that is kind of done by default in the IDE. And I don't really have to do anything special, to get that indentation. You may also notice that while I'm typing, if I start to type, it tries to fill-in code for me, which is awesome because then I don't have to type it. All you have to do is press your tab key to accept that ghosted code, and it'll put it right in for you. So that is another super nice thing about using an IDE. So at this point, we are going to talk a little bit more about variables and assignment statements. If you want to store values, you need to declare a variable. Because a variable is going to reserve a spot in memory for the value that you want to store. And you can declare a variable anywhere in the program. Typically, they're declared right before they are used. And to declare a variable, it's just the data type followed by the name of the variable. As far as naming your variables go, there are some C# rules that you need to follow to avoid syntax errors. And then there are some like industry standards that we follow. And as far as the syntax rules go, the names have to be unique and they are case sensitive. So lowercase number and number that starts with a capital N, those are considered different variables. If we are going to use multiple words, a standard, and this is just because the typing is a little faster, a standard is either to use Pascal case or camel case. Okay, so let's say I wanted to create a text variable, so it would be a string, and I want to store the department. They're working with a company and they want to enter the department name. So if I'm going to use camel case, I might say DEPT in lowercase, then capitalize my second word because you cannot have a space in the variable name. Okay, so department name equals IT. If I was going to use Pascal case, okay, and you can do the same thing. Pascal case capitalizes the first letter of every word. Still no spaces. Okay, but you can see how they are different. So this is camel case, and that's what I typically use. That's what I prefer. But there are a lot of people who use Pascal case. Okay, and it kind of comes down to a personal preference. Some companies might have a standard, okay, but that's typically how we do multiple word variable names. And it is a good idea to keep names descriptive. So saying something like integer X is not descriptive. Okay, saying something like integer age equals 20 is descriptive. So if X was supposed to represent age, we would have no clue. Okay, so using the more descriptive variable name is a standard. As far as what characters you can include in a variable name, you can have letters, digits, or underscores, but you cannot put in spaces. And you cannot use any reserved words. Okay, and reserved words are keywords in the language itself. So the word return is a keyword. Okay, you can see it's kind of purple, it's keyword. So you cannot use keywords as a variable name. Like we couldn't say integer return equals 0, that would give us an error because return is a keyword. So I would pretty much stick to camel case or Pascal case. As we progress through the course, there is an instance where we are going to be starting our variable names with underscores because that is a standard when we are creating private class fields. And so we'll be learning that kind of near the end of the course. Okay? But otherwise, we don't really start with any special characters. It's either, the lowercase or the uppercase letter. We already mentioned names are case sensitive, can't use reserved words. And there's no limit on the length of a variable name. However, most coders that I know do not like to create super lengthy names because it takes time to type them. And if you are going to use the variable quite a bit, it's just a lot of extra typing. So we mentioned when we create a variable that we have to tell C# what the data type is. And the data type is super important because that tells the computer the size of the variable. So it knows how much space in memory it needs to reserve. And so specifying the data type helps prevent errors because you can't put the wrong type of data in. So if I say I have an integer, it is a whole number, and I try to key in a decimal place, I am going to get an error. Okay, so it doesn't allow the wrong type of data to be entered, and it reserves space in memory for us. I did create a little table here for you that shows the different data types and then how big these data types are. We kind of started with the smaller ones and went to the larger ones here. Bit is very small, and then characters a little bigger, string is even bigger than that. And then I've got a description kind of giving you an idea of how much space that takes. And a bit is actually the smallest. A bit is a 0 or a 1. And a byte is 1 byte is a sequence of zeros and ones. Okay, so and every single letter and every single number has a specific sequence of 0 and 1s that are used to represent it. Assignment statements occur when you take your variable and you set it equal to a value that you want stored. So declaring the variable reserves the space in memory for the value, but it doesn't actually assign a value. You need an assignment statement for that. And the value that you are going to store is always on the right of the equal sign. The variable is always on the left. When you create a variable, you can assign it a value at the same time, and that is called initializing. If you create the variable first and put the value in later, that is assigning a value. So coming back to this little example, I have a Boolean, which is either true or false. So here I'm creating my Boolean variable and I'm putting true into it all in the same statement. So that is initializing. If I did this, and I don't put a value in, okay, that's just declaring. And then later on, if I put a value in, that is assigning. So assigning is basically two steps because you declare your variable and then you put the value in. And initializing is one step. Okay, and which is better? Honestly, it just depends on what you're doing in your program. Sometimes you want to create a variable and then you want to ask the user for input, okay, later on, and then that's when you put the data in. Okay, so it just depends on what you're doing. Okay, and so here's a similar example. Most of the time, if we are going to use a whole number, that's a number without decimals, we are going to use an integer. If there's a chance that you may store a very, very super large number, okay? And if we go back to that table, okay, this is what I mean by a super, super large number. Okay, so, and this should be negative. I can see somehow the negatives got taken away, but this is negative and negative to positive here. So super large number. If you're going to store a super, super large number, then you are going to need to create long. And the default is integer. So with integer, you just say integer, whatever your variable name is, equals, and the value. If you're going to do a long integer, then you have to use long. And then at the end of the number, you have to put an L. And the L stands for long. If you are dealing with a number that has decimal places, the default is double. Double is more accurate. It has more decimal places. If you don't care if the value is very accurate, then you can store it as a float, but then you're going to have to put the F at the end. Okay. If you are dealing with people's money, you want it to be accurate. So you definitely want double. Okay. In fact, I pretty much always use double. I never use float. Okay, because double has more decimal places and it is more accurate. And this example is actually a really good one to look at because you can see that I have two numbers and they're actually the same number. One is stored double and one is stored float. But then if you look at what happens when we print those out, you can see that the float value is missing the end of the decimal. It's been rounded and it's been rounded down. Okay, so it is not as precise as double. Boolean is either true or false. And so you basically just type in the word true or type in the word false. Boolean values are often used in if statements because all you have to do is put if and then the name of the Boolean variable. And the computer interprets that as if the variable is equal to true. And we'll look at that more when we get into selection statements. But the Booleans are used in all conditional testing, whether it be selection statements or repetition. Character is a single letter, single number, or a symbol. And the way that you would assign character is you use char as the data type. And then you put single quotes around one letter, number, or special character. Okay, and here's an example. And for string is going to be more than one character. And anytime you have more than one character, you have to put it in double quotes and it becomes a string. And this last example, you can see that I've got some pretty short programs, and they're just kind of showing you how these different data types work. So here I have got several different data types that I've assigned data. These are all initialized. And then I've got some write statements, write line statements that are printing them out. And so here I've got Booleans, okay, in addition to other data types, and we're printing it out. The variables and the data types that we've talked about up to now are ones that can change. So in a program, if I set keep going to true, down here, I can change it to false. Okay, and so you can do this with any of your variables. You can change what's stored. Constant variable is different. A constant variable is not going to change. Right? So if you have a value that is static, that should not change, you will make it constant. And an example of that might be a pay rate, if you're doing some kind of a pay calculator, or the hours worked. Okay, those are things that probably will not change. So if I was going to have something like hours, I want to set it to 40, I could make it constant, and that would make hours something that could not be changed in the program. If I tried to set hours to something else later on, it won't let me. Okay, same with pay rate. If I said constant, double pay. Okay, once I make that constant, that cannot be changed while the program is running. So as far as constant variables go, you can use any of the normal standard data types. What you cannot use is the var or var data type or static, and we're going to be talking about those later. I put that information in here just so that all the reference material for constant was in one place. Okay, but for right now, just remember that any of our data types can be made constant, and these special ones we'll talk about later on. As far as arithmetic operations go, the reason the computer and spreadsheets and that type of thing are popular is because you can pretty quickly do math operations. And so when we're working in a program, these are the different operators that we use. I think, addition, subtraction, those are pretty straightforward. Division, the slash has to go this way. Multiplication, we have an asterisk, not an X. We have an asterisk, and then modulus. So a modulus gives us the remainder in integer division. Okay, and I have a little example here. And by all means, you guys can actually key these in. And you should also be able to copy and paste if you wanted to. Okay, but you can see that I've got a couple numbers that I have declared and initialized, a couple strings. And then you can see that I've got some arithmetic, and I'm writing out the results. Okay, and you might think, how in the world can I add strings? Well, that's the most wonderful thing about coding is that one operator can do multiple things. So it can add numbers and it can also be used to concatenate or combine text. So when we use it like this, it's going to take this phrase and combine them. So if we run this, okay, you can see what that looks like. Okay, and again, here is just another example that you guys can kind of play with. And then we get to errors. So I've already shown you a syntax error, and that is usually a typo. So, forgetting a semicolon, forgetting a closing quote or double quote, forgetting that your variables are case sensitive, getting mixed up on the curly braces. Those are all very common errors. Okay, and then it will display the error to you, and you're going to need to fix it. Runtime errors. So you'll also know when this happens because you'll run your program and you'll get an error while it is running. So let me create a runtime error. I am going to do the dreaded division by 0. All right, so this is not going to get a compile error. Okay, but I got an exception error because I'm trying to divide by 0. Okay, so this is a runtime error. Okay, so you're going to know when you get these runtime errors. Errors that you can predict, like dividing by 0, we will be learning how to handle those. There is something called exception handling that we will learn later in the course. And so whenever possible, you do try to predict and handle those errors so that the program does not stop running like this one did. This is what you don't want to happen. So we've got syntax errors, runtime errors, we have logic errors. Logic errors can be hard to find. This is why you really need to test your programs because your program will run without errors, but the results are not correct. Okay, so the best way to catch these types of errors is to test your program. Okay, so logic errors sometimes can be found simply by walking through a program. So if this was logic that represented our morning routine, what is the problem here? So we turn off the alarm, we get dressed, we eat breakfast, we shower, and we drive to work. So hopefully you guys found the problem. If we do things in this order, we are going to arrive to work very wet because we have showered after we have gotten dressed. Okay, so this is a logic error. Seems silly, but this happens in programming all the time. So you have to test those programs and don't enter real large fancy numbers. Enter values that you know the answer to, so you can confirm whether it is running correctly or not.